Next up, we've got Lyle Gauthier. He's a master's student who's researching with Professor Eric Diller, and he's going to talk to us about the localization of a magnetic capsule robot for targeted gastrointestinal microbiome sampling. Take it away, Lyle.
Right. Thank you, Kimberly. And yeah, that's a bit of a mouthful, that one. So hello, everybody. My name is Lyle Gauthier, and like Kimberly introduced, I'm a master's student in the microrobotics lab under Professor Eric Diller. I'm here today to give you a window into my project, which is titled Localization of a Magnetic Capsule Robot for Targeted Gastrointestinal Microbiome Sampling. But before I get into the technical localization part of the topic, I'm first going to give a little background on the microbiome sampling part. So next slide, please. So over the past decade, as I'm sure you've heard and read, there's been a lot of research into the role that the bacteria in our gut plays in our overall body. Many studies have linked that the health of our gut microbiome is much more important than previously thought and can actually affect the health of our hearts and our brains, as well as the GI tract itself, of course. It's been a very popular topic, and the vast majority of the studies have actually been published between 2013 and now. So it's somewhat of a gold rush of scientific discovery happening. However, while the science has been advancing very quickly, the methods for collecting samples of the microbiome have not quite advanced at the same rate. In humans, the primary method for obtaining and analyzing the microbiome is still through stool samples, which can really only give a good representation of the later areas of the GI tract, like the colon and the large intestine. It doesn't quite paint a picture of the system as a whole. And most of the data that we do have on places like the lower stomach and the small intestine is obtained from animal studies. And the methods for obtaining samples in these studies are often quite invasive. And they often require sacrificing the animal to study its internal contents. Next slide, please. So this project is an effort to meet, there we go. Oh, well. So this project is an effort to meet this need for a new non-invasive and accurate sampling method. And what we're doing is designing magnetically actuated capsules, which you see on the left. These capsules are designed to be able to target specific sections of the GI tract for microbiome sampling. The idea being that the capsule is ingested, it moves through the gut to a desired area, it actuates and seals itself until it is excreted, and we can retrieve the sample for analysis. These capsules are designed to be simple and scalable without any complicated onboard electronics. And they work using simple magnetic mechanisms, which we can control and actuate remotely by applying low frequency magnetic fields. We also do have some capsule designs that can actually actuate themselves autonomously via pH sensitive hydrogels, which act as something of a trigger for the magnetic mechanisms, depending on the pH of the section of the GI tract that they're in. And those are being developed by my PhD student colleague, Priscilla. They're very neat. And as you can see on the right side, a challenge in designing and testing these capsules without any onboard electronics for communication, et cetera, is that we don't actually know where they are for in vivo conditions. This is a video of early tests that we conducted on pigs for these capsules. And as you can see, there wasn't really a way for us to tell where the capsule was. So we kind of had to randomly apply a magnetic field to try and open the capsule wherever it was in the pig. And that's what that wooden box is. It's actually holding a large permanent magnet. That's what we use to apply a magnetic field. So this is the primary focus of my project, is to develop a system which not only determines the position of the capsule, but also its state of actuation. Is it open? Is it closed? Did we manage to sample at the proper time, or were we late, etc.? Next slide, please. All right, so here's a look into how I'm approaching this problem. Without using onboard electronics for communication, I've decided to make a system to track the capsules based on the magnetic field that they emit. I'm building a system which uses a grid of Hall effect sensors to detect the magnetic field of the capsule. And based on the readings of each individual sensor, of which there's 16, I can apply a nonlinear least squares minimization algorithm to estimate what position and orientation of the capsule aligns with the values read by all 6 sensors. So essentially tuning where we estimate the capsule is in 3D space and orientation space that it emits a magnetic field that provides a solution for all of the sensors. And I do this not just for the capsule as a whole, but actually for each individual magnet within the capsule frame, because tracking each individual magnet and where they're pointing is the key to telling me what the actuation state of the capsule is. Again, is it open? Is it closed? So on the left side are some demonstrations of how I've simulated the system to work so far. The top video being an example of tracking the capsule as it moves through a spiral path, and the images below showing how it can be determined if the capsule is open or closed based on one of the previous designs on the last slide, which the more horizontally oriented arrows on the left side is a closed capsule, and the right side image where the magnets are more vertically aligned represents an open capsule. So on the right is also an image of the first prototype that I've built so far, and one of the ways that I intend to test it. We will have a robotic arm installed in our lab soon, and I plan to mount the capsules to it and actually track the capsule as it moves through a path to specific points. And finally, to give a longer range outlook into my plans, once I've tested and tuned the system, I actually intend to build an improved version, which we can then apply into future in vivo tests that we will be conducting in pigs, hopefully this summer. Something that we can actually strap to the pigs and watch the capsule move through the whole GI tract, and hopefully be able to estimate when it's taken a sample, or so that we can know when to actuate to take a sample. So that is an outlook into my project and my research status. And with that, I'd like to thank you all for listening.
Thank you so much, Lyle. I look forward to pig videos this summer.